Okay, one last little reminder on what contributes to the overall fitness of a population. We just went through how to add members to the population, more immigration and recruitment through natality. But we also have to look at the other side of the spectrum, mortality. So the number of individuals that die over a period of time, usually we reference 1 year, but it could also be measured over one season if you have a dominant season of mortality. So survival rates and mortality are conversely related. When one goes up, the other goes down. The longevity, or how long an animal lives, will contribute to how many individuals can be in a population at any one time, because they're going to stay there. And then you have your natality and your mortality and your immigration and your emigration playing a factor in the ins and outs. But then the longer lived animals will stay in that population longer. So overall decline in population is going to be due to mortality or animals leaving through emigration. So now we need to look then, I should add, mortality is often age and sex dependent. We know that it's sex dependent by having males often have higher mortality rates than females, especially with mammals, I should say. And that is due to a higher energetic requirement to maintain a higher home range. And then a higher or bigger area that they have to cover when they're looking for mates. And if they compete with other males to get those females during the reproductive times, then they have to have energy to be able to kind of maintain their territory. So they often expend more energy, need more energy, and therefore they have a higher mortality rate. So how do we measure the habitat? And it's important, we talked about the geographic habitat selection, where an animal occurs on the landscape, and then the home range. But within an animal's home range, they have those patches. And I briefly showed that on an earlier slide. But a patch is the area within its home range that it tends to use more than others. So for example, my home range is kind of northern Colorado. I go to Windsor sometimes, I go to Loveland sometimes, I might go to Wellington. That's my home range. On an annual basis, it might be a little bit bigger than that. Maybe it's all the way down to Denver with few excursions outside of that area. But my habitat patch, really for me personally, it's southeast Fort Collins. So really South Fort Collins, because I come all the way over here to Front Range, but East Fort Collins because that's where I live. So it's a small little subset of Fort Collins that I get most of my needs in. So that would be my patch. And when I talk about patches, that's really what we're talking about, habitat. It's that area of the home range that the animal's using the most. So within that habitat, we can assess, I have a couple ways of assessing how animals are choosing their habitat. We might choose to say a stand-based assessment. Basically, we compare two habitats. Maybe it's a ponderosa pine and an aspen dominated stand. And we might say, okay, which stand has more animals in it? That must be what they're choosing for. But the problem is when we do that is we're really only calling that stand by its maybe one dominant vegetation, and there could be a myriad of factors in there that's causing one of those two places to be better quality than the other. And we know, right, that the number of individuals in that habitat doesn't necessarily mean it's a better habitat. A species-based assessment then is much more accurate but much more time-consuming. So we might trap animals, collar animals, and track them through GPS or through radio telemetry. And in doing so, we determine which habitats they're using the most often. What is their patch within their home range? Which habitats are the most important to them, so that we know where they're getting most of their needs from. And you can, with this species base, you can go even farther. What resources are they using within that patch? Are they spending most of the time down in the riparian area, or are they spending their time on the upland? Is there a certain element in their habitat that's really important? Maybe it's a salt lick. Maybe it's something, a really small localized piece of the habitat that's very, very critically important to them. So these are two methods of kind of assessing the habitat, with this species-based being more time-consuming but more accurate. So getting into this habitat connectivity, we need to look at how are the connections between habitats important? Why are they important? We know that habitat size, right, quantity is important and quality is important, but how these individual pieces connect throughout the landscape is almost as important, if not more important. So across the landscape, you've got to think big picture now. The landscape connectivity influences dispersal, where animals leave one population and disperse into a new area or a new population. So they emigrate out of one, immigrate into another, or they start a new colony in that new area. But it also relates to migration. So we have a couple different things going on, dispersal and migration, but the bottom line is it's an animal trying to navigate across the landscape and arrive at a destination safely. So with dispersal, that often influences the overall population growth. If I can have one population disperse into another population and that increases our metapopulation, then we have a population growth. It might influence colonization. Do we get new areas occupied by a species? Or recolonization. Maybe a certain species has been extirpated from an area, but through dispersal, the animals recolonize that area later on. Migration, why connectivity is so important for migration, is because if you have poor connectivity and therefore the animals are not successfully migrating between two habitats that they use on an annual basis, they're going to overuse one of those two habitats if they can't get to the other one, and that will result in habitat degradation because they're so concentrated and they can't migrate. Or it will lead to an overall population decline because they'll all die during that migration period. So what influences dispersal? Some animals are dispersal specialists, some are generalists. Just like everything else, you can attach specialist and generalist to about any component of wildlife management. Some of them have very particular requirements and some of them can get away with a wide spectrum. Body mass, though, we do know has been shown to influence dispersal. A larger body mass means larger dispersal capabilities. That makes sense. Your Preble's Meadow jumping mouse isn't going to disperse from Colorado to Montana anytime soon. It would take too many generations for them to cross that far. But theoretically, an animal much bigger than that could easily disperse to Montana if the conditions were right. Trophic level plays a role too. The higher up you are on that trophic pyramid, like carnivores, they're more likely to disperse than herbivores. And home range size influences dispersal. When you have a large home range size, that's correlated also to your body mass and your trophic level. Therefore, they kind of are all wrapped up into one, but of course you then would have larger dispersal capabilities. They're already used to traveling larger distances. So how far do animals disperse? Well, of the individuals who disperse out of the source population, most of them will only go a short distance, but some can and will go quite far. I'm going to show you some examples here in a minute. If dispersal must continue over multiple home range distances, the animal may give up and settle into a suboptimal patch to save energy, or they may have run out of energy. So this is where that home range size can be a guide to how far that animal might disperse. If you have an animal whose home range is 10 square miles, then they may disperse 50 miles in one direction, and that might not be a real big deal for them. If you have an animal whose home range size is 10 square meters, then they're definitely not going to disperse 50 miles. Or if they try to, they're probably not going to make it that far and they'll settle in that suboptimum habitat. Let's look at mountain lions. It's a really good example of dispersal. So back in the 90s, it was very rare, 80s and 90s, really in the 80s I should say, it was very rare for people in South Dakota near the Black Hills to see a mountain lion. In fact, there was some studies done to see if they even had mountain lions, and they never proved that they were completely extirpated from the state, but they were not showing up. And definitely people didn't just see them running through their backyards like they do today. So there's been some conspiracy theories in this region that maybe the government planted mountain lions in to mess with the farmers and to, I don't know, eat their children or something. You think I'm making this up, but I'm not. And so they looked at where these animals came from, and it seems that most of the animals actually dispersed into the Black Hills, which was good quality habitat, but for a lot of years didn't have good deer numbers because of the agricultural practices in the area. As conservation practices took hold in the 80s and you got more deer, it became better quality habitat for a mountain lion. So we have two populations of mountain lions, one in the Bighorn Mountains of Wyoming and the other in the Laramie Mountains down here close to Colorado, that dispersed into this area. And then after this area grew, the population density grew, animals began to disperse up here to the North Dakota Badlands. And so they've done a lot of studies out of this Black Hills population of mountain lions on how far they're dispersing, and you can see some of these animals are going quite a long ways. And the male dispersals, Oklahoma City and all the way up here to Canada, went pretty far, and an average of 274 kilometers if you don't count the ones that died along the way. But the females didn't go nearly as far. The females definitely left some of the core areas where they were collared and followed, but they dispersed to the peripheral part of the population. So remember, it's our young animals that get booted out. They're looking for mates, or they're trying to avoid getting in scraps with more dominant animals, so they come to the edges of the population or settle just outside. And then we think that those animals, like I said, dispersed up here to North Dakota and kind of recolonized this area in North Dakota. So now we get several healthy populations of mountain lions, and people see them fairly commonly, and we think they just dispersed there naturally. Okay, so we're going to look at, there's three effects of successfully dispersing, three things that are highly important. The first is looking at the probability that the direction of travel from the source patch will end in the target patch. So what we're really looking at here is the angle from the center of the source patch to the outermost edge of the target patch, because the bigger the angle, the better that animal will hit a good habitat. And the angle will change with the distance to the patch. So let's look at it here. When we talk about angle, here's our source patch here, and here's our target patch here. So if you think about it, here's the center of our source, and we can draw this line being the angle here. So the angle A, if that animal leaves, has 360-degree choice on where to go. As long as it leaves within maybe this 45 degrees, let's say, it will eventually hit a target patch. And by a target patch, we're talking about suitable habitat. We don't know what this area is, but if this is a target of where it could end up. Now keep in mind, animals don't have a target in mind when they're dispersing. They might when they're migrating, but not when they're dispersing. So it's a pretty random choice. The probability is A, this angle, divided by 360. And as we said, that angle might change. If our source is over here, it's farther away, then our angle, not quite there, but our angle here is much smaller, right, than our angle here, because we had to stretch out to a farther area and pretend like I hit the corners there. My angles weren't quite right. The other thing might change is if my target patch was smaller, then my angle then becomes just this little tiny angle, which might be angle C. C divided by 360 would be much smaller than A divided by 360. Whew, that's a mess. So moving on then, that's one of the things that's really important. The second is the probability of not dying on the way. and I think I'm going to stop here and we'll continue this with part 3 of the video.